Hello everyone, Greg here to talk about using a contingency table. So there's this 2x2 table, and that's how you test for independence between two things. Here I'm going to use high school GPA and college GPA, and this is from section 11.2. And the reason I'm making this extra video is because we need to be able to do this when you have a list of data. So I'm going to use this list of data, which actually comes from the Chapter 7-8 review, but it's a good example for using the contingency table when you've got numbers in one column and numbers in another column, and you need to sort them and count them. So the first thing to do is type these into a list, which I did right before turning on the camera. So make sure they're still in there. Okay, now I can just go to stat and calculate the one variable statistics for list 1. So that's going to be the high school GPA. And then just move down, and it says that the median is 3.51. So you are allowed to do a little bit of rounding. So I'm going to use a 3.5. That's just easier for me to remember. So down here, the median is a 3.5. Now I need to do the same thing for their college GPAs, which is list 2. So stat, calculate, and now say list 2. And move down, it says it's a 3.42. So I'm just going to use 3.4. Okay. Now I need to go back to the table and start putting that information on the table. So I need to put one of them, high school GPA, up here, or I could put it right here. It doesn't really matter which order. I'm just going to put the high school up here, high school GPA. And for that one, the median was a 3.5. So I'm going to say those that were lower than 3.5 and those that had bigger than or equal to 3.5. It actually doesn't matter if you put the equals on that one or that one. At the end, if you're going to prove something, it's not going to make a difference. Then over on this side, I'm going to put the college GPAs. And for that, the median was 3.4, so I'm going to say less than 3.4 and bigger than or equal to 3.4. Okay, there's the setup. Now what we need to do is start counting the data. And I'm going to start with, ta-da, purple. So these people who in high school had less than a 3.5, they're going to end up in this column. Oh, and by the way, when I'm done and I add up all 4 of these squares, it should equal the total amount of people, which according to the calculator is 25 people. So just as a reminder, n equals 25. So when I'm done and I add up these 4 squares, that should be all 25 people. All right, now for the fun part, highlighting. So anybody's high school GPA that's smaller than a 3.5, they're going to be purple. Okay, so it's those that have less than a 3.5 in high school. So less than a 3.5 does not include the 3.5. This one and this one. And this one. And notice that I'm highlighting across because later on we're going to be looking at their college GPAs, so I just make it go across like that. Or if I had an actual highlighter, I would go all the way across like that. But you could just use a pen like this. All right, I think I have them all. So then I would just double check and make sure that I didn't miss anybody. So I just go through and keep saying smaller than 3.5 in my head, smaller than 3.5, smaller than 3.5. Okay, I think I got them. So for the purple people, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So when I am done counting these two, that should equal a total of 11 purple people. Now what I'm going to do is highlight these. If it's bigger, their high school GPA is bigger than or equal to a 3.5. And these people are going to be green. So if their high school GPA is bigger than a 3.5, bigger than or equal to 3.5, bigger than or equal to, sorry, I just say it in my head so that I don't forget. I guess I could say it just quietly in my head, right? So if I did it right with the purple people, basically I'm just highlighting everybody that's left. Everybody that's left had at least a 3.5 in high school. And then that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's 14 people. So there's 14 green people. 14 green people plus 11 purple people equals 25 people total. That is good news. Okay, now we need to figure out who goes right here. Out of the 11 people, how many of them show up right here? So what I'm going to do is, for everybody that has smaller than a 3.4 on their college GPA, I'm going to put a check mark. And at first, I'm not even going to pay attention to if they're purple people or green people. Just if their college GPA is smaller than 3.4, it gets a check mark. So smaller than 3.4, smaller than 3.4, smaller than 3.4. Sorry if I'm bugging you by saying it over and over again. Smaller than 3.4. No, smaller than 3.4. Smaller than 3.4. Okay, now it's time to count. So the people in here, well, for one thing, they have to be purple people, and they also have to have a red check mark. So out of the 11 purple people, how many got a red check mark? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10. And so there's 10 people that go here. And since the total has to be 11, well, that right there is the 11th person. So there's one person that goes here. Okay, then those people that have bigger than a 3.4. So I'll just put a dot for that. And the color of the dot doesn't matter. Just make a dot if their college GPA is bigger than or equal to a 3.4, which actually should be the rest of the people. Bigger than or equal to a 3.4. This is also a good way to double check that I did my red check marks right, because everybody else should be bigger than or equal to 3.4. Okay. Now I've got it all color-coded and ready to finish up the counting. So right here, these are the green people, and there's 14 green people. So I'll be looking at the green people. And for this box, they have to be green with a red check mark. So only look at green and look for a red check mark. So no, 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 yes, so that's 1. Here's 2. There's only 2. So there was 2 people that were green with a red check mark. Now this last box should be the green people that have a dot. So green people that have a dot. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I got 12. And then double check, this should have added up to 11, and it did. And this should have added up to 12, which it did. And then these two add up to 25. So that part's right. All right, that was the hard part. Now that we're done sorting the data, we can go ahead and do the claim. Is that high school and college GPA are independent. Or in other words, how you do in high school has absolutely nothing to do with how you do in college. Since I teach college, I sort of think we're going to be rejecting that. I think there is a relationship. And this I need to enter as a matrix. So hopefully you already watched section 11.2 where I show how to do this. So you go to matrix, say edit the matrix. It needs to be 2 by 2, and then just type in the new numbers, hitting enter each time. So that one's a 10, that one's a 2, this one's a 1, and this one's a 12. So there's my matrix A. And now quit and go to stat and tests, and it's almost at the bottom. It's called the chi-squared test, letter C. So this is saying it's your job to put the observed values in matrix A, and it's the calculator's job to put the expected values in matrix B. If somebody was messing with your calculator and they erased it, then that's okay. Just go over here to matrix. So put second matrix, and then right there is the name A. So just hit enter, and there it is. And then the same thing, if somebody had erased your matrix B right there, just go to second matrix, pick B, and then it fills it in, and then we're ready to calculate. So it says that the test statistic is 14.490. So I have chi-squared equals 14.490. And then the chi-squared distribution starts at 0 and then is skewed like this. And if we're using 95% level of confidence, then this is 0.05. And then I need a table of values, which hopefully I can reach without dropping a bunch of stuff. Okay, so here's the chi-squared. So usually I have a line down here because this is the chi-squared on the right and this is the chi-squared on the left. Well, notice that this test is right-tailed only. So this is just going to be chi-squared on the right, or you could just call it the critical value. And then the degrees of freedom, the calculator says the degrees of freedom is 1. All right, so if we're using 0.05, then that is right here. And then degrees of freedom 1 means go down by 1. So the critical value is going to be 3.841. So a 3.841 and a 14.49 goes way past that. So that means definitely reject. So we're actually rejecting this word independent. So if you just took the in off, that means they're dependent, or the opposite of independent is dependent. So high school and college GPAs are dependent. So basically, how well you're going to do in college? Well, it sort of depends on how well you did in high school. Now, that doesn't apply to each and every person, but as a general practice, it seems to be true. Thanks for joining me today.